Okay, now welcome everyone to this new session of African Plants Georeferencing the Trainers Workshop. During this session, we're going to focus on questions and answers, particularly for modules 1 and 2 of the course, which we have seen before. This is going to be an interactive session, and we're going to try some exercises together. So I propose that we start warming up a little bit, all of us. And so I will ask you to go to this web page up on the screen, menti.com, or you can use the QR code as well. And once you get there, you will be asked for a code. Please write it down, or John, if you can put it on the chat, the code for the first quiz. And I'm going to go into that quiz. I'm going to change screens, but so that you know, in that quiz you will find some questions that you need to answer online, and we're going to start seeing your answers live. Don't worry, your names will not appear, so you can answer freely. Don't be afraid to make mistakes. We're here just to understand better the concepts behind georeferencing. So I'm going to change my screen to our first exercise. I hope that you can see it on the web page. And the first question that we propose is, which of the following statements that you see down here, but you will see written on that webpage, which of these statements is correct? Are you being able to go to the page? John, if you can check if you can answer.
Okay.
So I'll give you some minutes to.
Yeah, I've managed.
Excellent. We have one answer. We have two answers. Three answers, four answers. Oh, we're getting many now. Excellent. We have 12 now, so we're still missing some. Okay, 13. Okay, I'll give you 1 minute more to answer, and then we'll start discussing it for those of you who haven't yet. We have another one. Another one. How many are we? 24 today? 24 counting us, so we're 22. We're missing still 7 people. Okay, I propose that we start looking at this. And if you're still answering, your answer is welcome anyway. But we'll start discussing so that we can move forward. So this is very interesting, this result here, because evidently you guys don't agree with the answers. And well, you agree on one thing, and that's about the precision of this coordinate here, which we're very happy about because we thought it was going to be one of the problems, but obviously it's not. This is correct. The coordinate of this coordinate has a precision that is missing 1 0 here. So it's 4 decimal places. So it is true. This statement is not correct as it stands. So you've answered correctly in this sense. So point to all of you. Now, let's start with the first one. Let's go back to the first one, which is latitude, longitude, and UTM are geographic coordinates. And this statement is false. This statement is false because geographic coordinates are latitude and longitude. Those two alone. That's what we call geographic coordinates. UTM is another coordinate format. Yeah, if you want to talk, go ahead, John.
I just didn't want to interrupt. Yeah, so what are UTM coordinates if they're not geographic coordinates? They are projected coordinates. Remember we talked about projections and the universal transverse Mercator projection. So those are numbers that apply to a flattened map, not to the model of the surface of the Earth. That's why they're not geographic coordinates.
Thank you. Thank you, John. So this one is incorrect. Let's move to the third statement, which is the coordinates given here, which is a pair of coordinates that we can assume is latitude and longitude, represent a single location on Earth. This was the most voted option, but is incorrect. And I would like to invite any of the people or anyone really to tell us why this statement is incorrect. Why this pair of coordinates do not represent a single location on Earth. We have a message on the chat. Precision is low. Well, it's true, precision is low, but we can have a single location with a very big uncertainty. It's still a single location, so that's not the reason.
We can also have a single location that is large. which this would be. So this you might imagine to be something like a grid cell that's precise to 0.01 degrees. So a 1/100th of a degree grid cell is what this would be.
They're also proposing that we don't have directions, south, north, west, or east, but we actually do have that, because in these coordinates, we have a -15. We assume that we're writing first latitude and longitude. So that minus is telling us that that is south in latitude. And we have a positive number for longitude. And that is telling us that the longitude is east. Remember that latitude and longitude can be positive or negative. Positives are for latitude is north and for longitude is east. And negative for latitude is south and for longitude is west. So we do have, because we have signs here, minus and not written, but a plus, it's a positive number, we do have the hemispheres implied in these coordinates. So there is another reason why having a coordinate alone does not tell us a particular location. We're missing something here. What do we need for a coordinate to refer to a single location? It's something that we talked about many times. Any other ideas?
Could it be because of the geodetic denim? It's not specified.
Yes, exactly. Good on you. Yes, yes. That is the reason. Exactly because of that. Because remember that always geographic coordinates need a coordinate reference system or a datum that tell us where are we measuring those coordinates from, the origin and the axis, how are we orienting that on Earth? Because if we don't have that reference system, we could be starting to measure those coordinates at any point on the Earth. And so depending on where we start and which direction we go, we will be defining a different location. So yes, we need the coordinate reference system or the datum. That is exactly the reason for this statement to be incorrect. Yay, excellent. Okay, so we're going to go to the last one, the last statement, which is the only one that is correct. That is, this longitude, 13 point blah, blah, is to the west of the longitude 15 point blah, blah. And in here, let me draw a little bit on the screen. We measure longitudes from reference or prime meridian, usually the Greenwich meridian. So this is the 0 longitude. Sorry for my writing here, the 0 degrees longitude. And so we start measuring. To the east is positive, to this side. And so we start 1, 2, 3, 4, etc. longitude. And so we get to 13. Sorry, my mouse abilities are terrible. And as we keep going, we go 14, 15, and so 15 is further this way, so it's to the east. We're moving east when we move to the right. So here we're going to the east in longitude, and so 13 is to the west of 15. It's moving to the other side. That's why this statement is correct. Are these we're going to go back to this with more exercises in a moment, but is there any question about what we just discussed? If not, we're going to move to the next exercise, which is this one, which you should be able to see in the same webpage that you were at. Can you see it?
Yes.
Okay, excellent. So here we have a location description that has an elevation, a depth, and a distance above the surface, and we need to choose which of the pictures. You have to pick which picture represents the that description. We have one answer. Two answers. We're at 7, 8. I alert you all that this exercise is tricky. Okay, we have 9 so far. We can wait a little bit more, see if we get any more answers. Okay, 11. Twelve. Okay, so far it seems that everyone agrees that the first one is not correct. And that is fine. That it is not correct, the first one. So for those of you who are still voting for the option, you already know that this one is not the one. So does anyone want to explain? Does anyone want to speak up and explain why the first one is not correct? Anyone?
Thank you so much. I can say that the object must be located on the elevation of 450 meters, which I don't see that on the first one is located on that elevation.
Okay, thank you. Thank you for speaking up. In this case, the elevation in this first spot, the elevation is actually 450 meters. Even though it doesn't look like it, because it looks like it's down here. What we take to refer the elevation is this surface. Our reference is this surface here, is the surface of the water. So this surface of the water is at 450. And so the elevation is still 450 for this one. There are other reasons why this one is not correct. Now, well, let's look at it. So, we have something on the chat. Yes, the depth is greater than 3 meters. That is true. That is true. It is at a depth of 4 meters at least. So that is one of the reasons. Yes, that is correct. The depth is 4 meters. That is one. And the other reason is that we're below the surface. It's like if we had digged a hole, we go to the bottom of the lake, and at this point is 4 meters, and we dig a hole 2.5 meters deep. And so we have a distance below this surface, which is our reference now, that is between the water and the bottom of the lake. And so there is a distance below this surface of 2.5 meters. So in this case, the elevation would be 450, the depth would be 4 meters, and the distance above the surface would be minus 2.5 meters. Do you all understand this case? If you have questions, this is the moment. So let me go back to some concepts here. Let me see if I can go back to the presentation. This one. So just as a reminder, elevation is a measure of the vertical distance, either land or water, above a vertical datum. In this case, we have a similar case here where we have a little mountain and a piece of lake or sea here. What we're using is the mean sea level. And so even though we can be at the bottom of a lake, we're measuring from here the elevation, because this is our reference surface for measuring elevation. And so in the case that we were looking before, elevation is measured with respect to that reference, and so it is 450. Then the depth is a measure of the vertical distance below a vertical datum. In our case, would be that surface of the water. And so as our companion here was saying, the depth is greater than what was in the description. It was like about 4 meters. So we had a depth of 4 meters. And remember that depth are always not negative, that is 0 or positive. And then we have the distance above the surface, which is called this way, but it can actually be above or below the surface, which is a measure of the vertical distance over a point of reference. And this point of reference can vary. We can be measuring here, for example, this little bird. Our reference surface is the surface of the water. That is the change between water and air, that interface. So we're measuring the distance above that surface. If we're digging a hole at the bottom of the lake, our reference surface will be this interface between water and the bottom, the land at the bottom, and we can have a distance below this surface. And if we're measuring just from the land, we can have this interface between land and air, and so we're measuring a distance above the surface. Because the concept is called distance above the surface, but it can be above or below, it can be positive or negative. If it's above the reference surface, it will be positive, and if it's below, it will be negative. So in this little drawing here, we have two that are positive and one that is negative. So going back to our quiz here, you see this is our surface, reference surface to determine distance above or below the surface. Is the interface between the water and the land at the bottom of the lake. Okay, I'm going to move to the second case, which is this one that has a bird flying on top of the lake. For this one, the elevation is 450 because we're taking the vertical datum as our reference to determine elevation. And here where you have the reference that we're taking, really, that is the mean sea level. And so this dot here is at 450 meters of elevation. It has no depth. It's not underwater. So this one could not be, just for that reason, this one cannot be correct. Because for depth to be 3 meters, the little bird should be swimming in the water. So depth, there is no depth here because we're not underwater. So if we were to complete this field, and this is important, we will leave it empty. We do not put 0 meters. We do not put NA. We do not put a dash. We just leave it empty. And then we have the bird is flying on top of the lake, 4 meters up. And so there is a distance above this surface now, this reference surface, which is the interface between air and water, 4 meters. So the distance above the surface would be, for this case, 4 meters. Now we move to the third one. The third one, you cannot see here, but the point there is here on the bottom of the lake, at some point of the bottom of the lake. So, which is the elevation here? Again, we take the mean sea level as our reference to determine the elevation. And so this lake is at 450 meters of elevation. So elevation is 450. Depth here is how many meters are we going down within the lake? Well, it's about 3 meters. So depth is 3 meters. And the distance above the surface, so far we're fine here. And the distance above the surface, to do that, we have to be on or below or up the surface. So which is our surface, a reference surface here? The interface between the land and the water. And so this one is just on top of it. So it's at 0 distance above the surface. So in this case, all the information that we have is correct. And this one, the last one, is very tricky because it might seem very similar in some things to the previous one, but let's look at it in detail. So for this one, again, our elevation is measured with respect to our vertical datum. In this case, we're going to take the elevation of the surface of the lake, which is 450. We are indeed at a depth of 3 meters. We're underwater 3 meters. So we're fine up to there. And now we have to understand distance above the surface. Here, since we're not referring to any other surface but the top of the lake, it doesn't make any sense to report distance above the surface, because this would be a distance below the surface, which will be this one, which we already have, because we account for that when we talk about depth. This is already reported as depth. So distance above the surface doesn't make sense here, and we should leave it empty. It's not 0 meters, it's empty. Because if it was 0 meters and we were referring to this surface, we would be just here at the surface of the lake. If we were referring to this one, we would be just at the bottom, and that would be 0. But in here, we're reporting this value as depth, and distance above the surface does not come into the equation. Are there questions about this? Anything on the chat? Yes, Benjamin raised hand. Speak up.
Yeah, thank you, please. So what I want to know is, with regards to the fourth picture, because the reference point is sandwiched in between the surface that we have and below, if you are recording this in the database, do you leave the distance above the surface empty? Hello, please, did you get my question?
I got it a little
Hello.
cut. Can you hear us there?
So should I type it?
Yes.
Yeah, I can hear you.
I think I understood perfectly well.
Oh, okay. I got it cut.
Let me restate it and see if I have it correct.
Yes, please.
So the question would be that if you have a position, a vertical position that's sandwiched between two surfaces, like in the fourth example in the lower right, in such a case, would you leave the distance above surface empty in a database? And the answer to that
Yes,
is
please.
yes. The answer to that is yes.
Okay. Yes, please. Thank you.
Welcome.
Any more questions about this topic? Okay, in the meantime, remember that all that we're reviewing here, I'm getting some back. John, can you turn off your microphone, please? Sorry, all that we're reviewing here is our concepts that we have seen during module 1 and 2, and you can always go back to those sessions to refresh, to review these concepts. And if there are no more questions about this elevation, depth, distance above the surfaces, we're going to go back to some things. No, let me see. How is it best to go? Yes, let's go here, and let's do some more exercises here in a different format. So geographic coordinates. We talked about this in the first exercise that we did. And we know that geographic coordinates can be in different formats, that they have limit values for latitude and for longitude, and that they have different precisions. So what I'm going to give you here is a particular pair of coordinates. And I'm going to ask you to provide me with the format and the precision of these coordinates. You can either write it here on the chalkboard if you want, or you can say it, or you can write it on the chat. You should be able to annotate the screen, no problem. Wait, sorry. So we want the format and the precision of these coordinates. We have a hand raised. You can talk if you want.
But error.
Oh, okay.
Answer in the chat too.
Okay, we have two answers in the chat. Oh, so there is a question from before in the chat that I want to clarify, that these that we're doing here are exercises for all of us to resolve during this session. This is separate from the exercises that you have to hand in on Saturday. Those exercises that have their own file are individual, and each of you have to hand it in by Saturday. So here we're just doing another practice all together. Okay, so we have here decimal degrees, decimal degrees, decimal degrees, decimal degrees. Well, everyone agrees so far that these are decimal degrees. And then for precision, we have 0 point, let me see if I can type it here. I'm gonna write it, oops, oh, it doesn't allow me to, what am I doing wrong? That's one option that you have. Oops. Wait a second. I'm sorry. Let's write it in white so that you can see it. That's one option that you have put in the chat that someone agrees to that. Someone says precision is low. Someone is pointing that we don't have the same precision for latitude and longitude. So check this out. And we have anything else? The same precision, someone is saying, I'm putting it exactly as it's appearing on the chat, 001 precision. Okay. So, oh, here we have an annotation that was from before. That shouldn't be here, oh, sorry. So, we all agree that these are decimal degrees, and that is perfect. Good on Oh, there is a comment. There is a comment there on the chat that is very interesting. Very interesting. That it says maybe there is a 0 at the end of the longitude. Let me draw it there. Let me draw that 0 here. And we're going to talk about that 0 here in a moment. But it's a very interesting observation. So back to the format. Yes, we are all in agreement. These are indeed decimal degrees. These are decimal degree coordinates. So we have a latitude. Remember that we have a minus here. It is showing us that this latitude is south. This coordinate is longitude, and since it's positive, is to the east. Okay, so if we look at the latitude, we have 4 decimal places. So for this latitude, we have a precision that is indeed 0.0001, 4 decimal places. So this is correct for the latitude. For the longitude, we have 3 decimal places. And so 3 decimal places would be, I'm going to add here to this one, 0. Let me put a comma or a point. 0.001, 3 decimal places. This 0.001 would be the precision of this coordinate. Now, if we're talking about the pair of coordinates, we have to report the precision of the one that is less precise, because we have to be conservative. We cannot assume that this is more precise than we're actually seeing. And so if we were to determine the precision of the pair of coordinates, it would be 0.001, 3 decimal places. Now I want to go back to what Cecilia was saying on the chat. What if there is actually a 0 here that we're not seeing because it's truncated or is rounded or whichever of those options? Well, first, we're not seeing it, and so we cannot assume that it's there. So if we're given these coordinates, we don't know if there is a 0 or not. So we have to be conservative and assume that if it's not there, I cannot make it up. Otherwise, I'm saying I would be saying that the coordinate is more precise than we really know that it is. So we would have to keep, unfortunately, this precision. It is true, however, that in some databases and spreadsheets and the like, when we put a 0 in the last decimal place, it takes it out because it has no meaning for the database. Unfortunately, for coordinates, it does, because it tells us about precision. And so you have to be super careful when you're entering coordinate data into spreadsheets or into databases that this doesn't happen. So every time you enter something that has a 0 at the end of the coordinate, make sure that the database is not erasing it, because you're losing precision, which is what happens to us here, because we cannot determine if it was there or not. Are there questions about this pair of coordinates? Otherwise, I'm going to move to the next one.
Sorry.
Yes.
I wanted to know if the coordinate format will have the impact on the precision.
Well, the coordinate format per se doesn't have an impact on the precision, because the coordinates have the precision that they have. But when we convert between formats, we can have an impact on precision. Why? Because the other system that we use, the other format that we usually use, is on a sexagesimal base, that is degrees, minutes, and seconds. And so when we convert that to decimal, we end up with sometimes with infinite decimal places because of how the conversion is done. When we do the divisions, we end up with infinite decimal places that we have to round up. And so that can result in problems. And if we're not careful, we can be introducing false precision there. So the format itself does not influence the precision, but the conversion between formats does. So we have to be very careful. Should I go to the next one? So in this one, we want you to do exactly the same, to provide the format and the precision of these coordinates, of this pair of coordinates. This one is a little more difficult, and you might have to take some time to think about it. We have some answers for the format, degrees, minutes, and seconds, degrees, minutes, and seconds. So far, everyone agrees. And let's see who dares first to tell us the precision of these coordinates. Degrees, minutes, seconds. And the precision? How do we calculate the precision of these coordinates? Precision, someone here said 0, 0, 0, 0. Well, let me write it here. I'm gonna write here the option that Benjamin just provided. 1, 2, 1, 2, 3, 1. Okay. That's one option provided. Anyone else? Okay, let's start analyzing what we have here. So we have coordinates that are in degrees, minutes, and seconds, as you all said. That is correct. There is someone else here providing another precision that is 1, 0 more, I believe. 1, 2, 3, 4, 5, 6, 1. Okay, that's another option. Oops. Oops, there. Okay. So coordinates in degrees, minutes, and seconds. As we were saying during the other sessions, when we have coordinates in this format, we usually express the hemispheres with letters: north, west, east, south. And we have here the degrees, the minutes, and in this case, we have seconds that are decimal seconds, right? The precision is here in this last, let me put another color, in this last digit here, and in this last digit here, right? So it's 0.1 seconds would be the precision for these coordinates. Let me write that down. 0.1 seconds. Okay. 0.1 oops, sorry. 0.1 seconds is the precision for these coordinates. Are we all in agreement with that? Because we have to move from here to calculating the actual precision. Oh, one thing, someone is having difficulties logging to the current quiz. This is not a quiz, this is a presentation, it's part of the presentation. So we're just working on the presentation. So keep on Zoom, and when we go to the next quiz, I will let you know, and there we will tell you to go to a web page. But this we're working on the presentation, which, by the way, you can write on the presentation on Zoom. I have enabled you to draw on top of my presentation if you want. So the precision of these coordinates is 0.1 seconds. Now, when we report precision, in which unit do we need to report it? How do we report precision? In which unit? Anyone? Okay, I'll answer my own question. It is, we report precision in degrees. And so we need to convert this to degrees, to decimal degrees. And so here is where the trick comes. The precision is 0.1 seconds, but we need to convert this to degrees. And so what we do is say, well, we know that in this system here, in this format here, which is hexadecimal, 3,600 seconds are 1 degree, correct? 360 seconds are 1, let me put it here, seconds are 1 degree. Are we in agreement? And so what we have to do is calculate how many degrees are 0.1 seconds. So if you remember from school, I don't know how to say this in English. How do you say regla de tres simple in English? This kind of calculation, how do you call it? We call it in Spanish regla de tres simple because it has 3 values with which you solve for the missing value. Okay. That's very different from how we call it. But basically what we have to calculate is this value based on these 3 other values that we have and the relationships that we have. So if 3,600 seconds is 1 degree, 0.1 seconds, how many degrees is that? And this is, let me do that, put the correct amount of 1, 2, 3, 4, 2, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 8. Let's truncate it there. But this will be the value that actually continues to the infinite 7, 7, 7, 7, 7, 7 at the end. Okay. This is the conversion of these seconds to degrees. So we're converting this precision to decimal degrees. Now, You see that this can go to the infinite there with the decimal places. So how many decimal places do we keep? Well, the recommendation is to keep 7 decimal places. And that is so that we don't make up false precision. Because otherwise we're saying it's much more precise than it actually is. So if we keep 7 decimal places, we will be keeping with the correct precision. So that is 1, 2, 3, 4, 5, 6, 7. Let's see, because it gets one more, no? 3, 4, 5, 6. There. So that would be the precision of these coordinates in decimal degrees, which is what we need to report. So this is the one that we need to report. Is this one? Is this calculation clear for everyone? There's a question on the chat that it says, is it right to conclude that a precision is the same as a second? No, in this case it's 0.1 second because of how this is given, because of this coordinate here. If this coordinate was up to the 11 and did not have decimal places at all, that would be a second. If it had 2 decimal places, it would be 0.01 seconds, and we would have to convert that anyway to degrees. Okay, so we're going to erase this one. Let's see if it allows me so that we keep the slide clean. Okay, so this is about coordinates. It's going to be super important that you come back to this and make sure that you have understood the thing about precision, because we're going to use it a lot, and you will surely have to convert coordinates when you're georeferencing. And it is, if you remember from our previous classes, the coordinate precision is one of the sources of uncertainty that we can have. And so when we calculate the net uncertainty of a georeference, this is going to affect that uncertainty. So it's important that you make sure that you have understood how to calculate and what the precision means. Okay, I'm going to clear all drawings. And what's going on here? I'm annotating. Okay, this we have seen, elevation. So we have another quiz that we can go to, but maybe we can make a break here that we have seen this part, and we can move on to the next quiz after the break. I see a hand up.
Hello.
Hello.
Yeah, I want to find out the difference between the accuracy when you pick you pick a coordinate with the GPS and this precision that we are discussing. What's the difference?
That's a really, really good question. Thank you for bringing it up. When we record coordinates with the GPS, those coordinates come with a precision that is also the number of decimal places of those coordinates. And so, for example, if you have your GPS set to decimal degrees, you will have, I believe it's either 6 or 7 decimal places on the GPS. So that is going to be your coordinate precision. Now, the GPS has other errors associated that have to do with the amount of satellites that are available, the environmental conditions, the climatic, the weather conditions, and so on, that can affect the efficacy of the GPS determining those coordinates, but that is reflected in the GPS accuracy, which is a source of uncertainty. So when you're measuring the coordinates with the GPS, you will record the precision of those coordinates, which is the number of decimal places if you have it in decimal degrees. If you have it in degrees, minutes, seconds, you will have to convert it. But you will also record the accuracy, and the accuracy is going to be one of your main sources of uncertainty when you're measuring with GPS. Does that answer your question? Oh, John wants to say something.
Did you have a further question first before I say anything more?
Okay, so from what Paula was saying, I get the sense that the precision more or less kind of counter the error or the uncertainty that the accuracy of the coordinate provide. Is that so?
Yes, the things can interact with each other. And specifically in the case of the GPS, Paola's saying there are two distinct things that happen. One is the GPS will give you a coordinate, and that coordinate has precision. And depending on that precision, there are uncertainties. But the GPS also gives you those coordinates with an internal measure at the conditions at the very moment when the coordinate is taken about the accuracy, which is environmental and separate from the precision. Those two things are both sources of uncertainty. So the GPS accuracy, the GPS itself is actually calculating based on what it's seeing from the satellites, how bad the coordinate is that it's giving you. And it's saying, listen, the coordinate I'm giving you is only good in my estimate within 5 meters because of what I'm seeing. So that's 5 meters of GPS accuracy uncertainty. But if you take the GPS recording and it gives you 6 decimal places of precision and you only record 3 of those, then you're throwing away all kinds of accuracy and precision by not recording all the decimal places. So depending on what you record from the GPS, you could be affecting the total uncertainty. The other thing I wanted to add about GPSs is that though one of the ways that you can see coordinates is in decimal degrees, maybe to 6 decimal places, that's not the only way. The GPSs allow you to configure what you see, and you can actually record in degrees, minutes, and seconds. And modern GPSs usually record to 1/10 of a second, just like that last example that we saw that Paula put on the screen. The interesting thing is that the most precise possible coordinate format that you can get out of a GPS is that one, the degrees, minutes, and seconds to the nearest 1/10 of a second, because that's more precise than a decimal degree to 6 decimal places. And you can confirm that by comparing those two numbers. So that's an interesting outcome. The difference is not very great, but it's real.
Thank you very much.
Mm-hmm. So
Okay.
Bernard has asked if we can go through our pre-course exercises today.
I just answered that. We're going to try to keep center first with module 1 and module 2 concepts. However, can you mute yourself, John, please? However, in module 2, we went back to Darwin core. So we're going to go back into that like 10,000 times during this course. So since pre-course exercise was about Darwin core, we're probably going to see things that are relevant to that. But we want to keep it to module 1 and 2 first, and we'll try to leave some time to answer further questions about the pre-course exercise if we if we have some minutes left. But don't worry, we're going to talk about Darwin Core, and we will probably get answers about the pre-course exercise during this session as well. So if you all agree, we can take a short break, 10 minutes, and we come back and see the next exercises. Are we good?
Yes, that's fine. Thank you.
Okay. Okay, well, see you all in 10 minutes then. Okay, so we're coming back, and I'm going to share my screen again. I'm going to share something with you first, because maybe you're wondering. So I'm going to present something that is very important for me. That is this thing on the screen, that is the mate. This is what I've been drinking all this time, and what I will keep drinking during all the modules. This is a beverage that is kind of a tea, that is something that we drink in Argentina, Uruguay, Paraguay, Brazil. It's a native drink that is made out of yerba mate, which is a plant that we cut very, very small, as you can see on the image. And we have a straw, and we pour hot water into it, and we drink that hot water through the yerba mate. And so it's like a tea. There are variants to it, so you can also have it cold, very, very cold, and also you can pour juice into it, and that has another name that is called tereré. It's a Guarani word. And so in case you were wondering what is that I'm drinking all the time, mate. I encourage you to try it. It's a very good companion. Okay, so
One more thing.
yeah.
There's a huge culture around the mate. It's not just you drinking. Often it's shared. You'll drink some from the straw, and then we'll fill with water again and pass it to the next person, and so on. It's a very nice tradition.
Yes, it's a community thing. From one single mate, we all drink together. So
Paula's sharing her mate with you visually.
Yes, I hope at some point you are able to visit, if you haven't yet, South America, and you will have the opportunity to try it with us, with the natives here. Okay, so that said, let's do some more stretching, some more exercises, and see what happens with the concepts of particularly module 2 now. So I invite you to go to the Menti webpage and introduce this other code here on the screen. You can also access it through the QR code. And we're going to go through some more questions. So let me change here to, oops, no, not that, but this one here. Okay, so in this question, the idea is that you have to either agree or disagree with the statements that are on the screen. John, you wanted to say something? I thought, okay. I believe you can see it as a scrolling little dot that you can put into agree or keep a disagree. So let's wait for our first answers. We don't have any yet. Okay, we have some now. Whoa. Okay. I really like this kind of exercise, this kind of graphics, because it can show us that if we agree, if we more or less agree or disagree, if we disagree, and we have the counts for each one. So it's interesting that for some of them we don't either agree or disagree, but we're in the middle. So we're going to have fun with this exercise. We have three answers so far. 5 answers. So these are some of these concepts we have seen during the first module in the geographic concepts presentation. And some of them we have seen in the locality descriptions, types and descriptions presentation. And the others we have seen in the georeferencing. No, also in the location types presentation. So this is actually all module 1 still. Okay, we have 9 answers. I hope there are some more coming. Let's give it a moment more. Okay, 12.
The answers keep drifting back and forth and coming back to the middle.
Well, that's the problem with averages and mean values.
It's also the problem with having people go first and other people trust that they did it right.
True that. Okay, we have 13 so far, and 14. Okay, but for the sake of time, while you finish answering, we will start talking about the first one. So The first one is the corrected center of a location is the point within or on the border of a feature that minimizes the geographic radius. So there is people who disagree, that say that this statement is incorrect. A couple of people that are towards the disagree but are not sure. Some people that it is probably true, and two people that says, yeah, this statement is true. And the correct answer is this statement is true. The corrected center of a location is a point within or on the border of a feature that minimizes the geographic radius. And I want to go to, give me a second, to the presentation here to remember a couple of things that we've seen before. If we have a given feature, in this case it's a town, and we can determine the boundary of the town and the extent, which is what's inside that boundary. That boundary has limits in latitude and longitude. And so provided those minimum and maximum latitudes and longitudes, we can determine a center that is a geographic center. If we draw a circle around it, around that geographic center, we'll have a circle like this, right? That is a circle that corresponds to that geographic center, including all the town inside it. And we can set a radius of that circle that goes from the center to the circle itself. Now, this is not the minimum circle that we can draw around this town. There is another circle that is a little smaller that can still include all this town. That is this circle drawn in yellow here. So this circle is smaller than the red one and still includes all the town. Now the center of this circle is not the geographic center that we determined before. It's a little moved to the side. So this center of this smaller circle is the corrected center. And what we're trying to do here is to minimize the uncertainties, to draw the smallest circle possible that includes all the location, in this case, the town. And so we determine for that minimum circle, a center of that circle and a radius of that circle. So that what it's doing is minimizing the radius. You have to keep in mind that this yellow circle in some cases is going to be smaller than the geographic one, and in some cases it will be just equal to the geographic one, but it's never going to be bigger, because the idea is that we try to minimize it. So it's either the same or smaller. So the this radius is trying to minimize the uncertainties. So the corrected center, I'm going to go back to our quiz here. The corrected center is the point that is either on the border or inside the feature that minimizes the geographic radius. So if we go back to some definitions, the geographic center is the midpoint between the latitude and longitude extremes, and the corrected center is the point that minimizes the geographic radius. Let's go back now to the quiz and look at the second question. The second question is, the location Mount Kenya is of the type geographic feature only with obvious spatial extent. And in here we have a lot of variation in the answers. Some think this statement is correct, and some people think it is not. And in general terms, it is not correct. And I'm going to explain why. Determining the limits of Mount Kenya can be very difficult. And so its extent, its spatial extent, is not obvious. So this would be a geographic feature only because it's a mount. That's our type of feature, mount or mountain. But it doesn't have an obvious spatial extent. So let me go back now to what we refer to as locality types. We had different kinds of locality types. And when we have only geographic features, we had different cases. Ones that have an obvious spatial extent, which we can determine unequivocally where the boundary is, and some that do not have that obvious spatial extent, which is usually the case of mountains. Mountains tend to fall in here unless we find some geographic gazetteer or other kind of source that tells us no, the limit is this line that can be, for example, an elevation line. If we find that source, we can say, well, the spatial extent is obvious because it's well defined, and this is the source of that information. But in general terms, it does not have, they don't have obvious spatial extents. Just as a reminder, within locality types, we had geographic features only, offsets that included distances along paths, headings in different directions. We had locality types that are coordinates, either geographic, UTM, or grid systems. And we had a series of difficult localities that we're going to talk about in a minute because it's part of the exercise as well. So let me go back to the quiz and we'll come back here. The next one is if a location description can refer to multiple unrelated features, we should not georeference it. And here we also have some variation. Most people answer that it is, they agree that we should not georeference it. And that is correct. We should not georeference it. And here is the trick. This word here, unrelated features. If we have unrelated features, means that the features are separate and they have nothing to do with each other. And we have no way of telling which one the location is referring to. And so if we cannot tell which one it is, we should not georeference it. And the next one, the next statement is, for a location that is demonstrably inconsistent, we should georeference choosing the most specific part of the location description. So in here, most people disagree, but there are some people that agree. And the answer is also tricky because in general terms, if the location is inconsistent, we should not georeference it. However, as I was saying at the beginning of this session, there are some decisions that we have to make when we are georeferencing. And there are some criteria that we can follow. And I'm going to give you an example. If we have a location that has only a locality description and we don't have any other fields, we don't have the province, the country, the water body, we don't have any other information. We have only very specific information, and that information is inconsistent. Or we have only two fields, and those two are inconsistent, we should not georeference that. Why? Because we cannot tell which part of the location is right or wrong. Where is the mistake? Now, if we have a full record that has a lot of information, and we have the locality that is super specific, and we have the county and the municipality and the country and a lot of information, and the province is wrong, and in the province field we have another province that is just nearby, then we could take the decision of saying, well, I suspect that this location is correct, but someone made a mistake when they put the province. And so I'm going to georeference it anyway with all this information, making a note that the province is wrong in the location that I'm looking at. As I was saying, it's very tricky because it's a very difficult decision, and we have to take a lot of things into account and see all the information that we have and report the criteria that we're using to do that. So it's very case specific. So we have to analyze each location in particular. But again, in general terms, inconsistencies should not be georeferenced. So I'm going to jump here. John wants to say something, yes.
Yeah, a commentary about the inconsistency thing, another tricky bit, can happen when something looks inconsistent, but it's actually only inconsistent with current information. In a historical context, at the time when the locality was written, it might have been perfectly correct. So what's a situation where this might occur? A very common situation where it would occur could be illustrated by the Democratic Republic of Congo, where the administrative divisions have changed many, many times. And sometimes the same name is used historically to refer to slightly different geographic places. So at the time in history where the location was recorded, it could be that a particular first level administrative division was recorded and it was correct at that time, but it just doesn't happen to be correct now. So in a case like that, and if one is aware of such things, one could see that if you took it in a historical context, everything would be consistent. And therefore, you could conclude that the only thing wrong with the description, if you were to say that's how it is today, is the administrative level. So that would be a case where you would georeference anyway, because you're able to actually solve the inconsistency and show that in the context where the thing was recorded, it was actually okay. Another thing that I wanted to say quickly, can you go back to the examples in the quiz? And that is the third question here. So the idea is to distinguish between unrelated features and related features. And one way that you could maybe determine or ask yourself if it makes sense to georeference or not is to think about those features. So an example of unrelated features is the following. You have a town in a country, but it turns out that that town name is actually represented in 3 different places in the country. There are 3 different towns by the same name. So if you think, how would I georeference that? You'd go into the steps of georeferencing and say, okay, where will I put my corrected center? And you think about that, you've got 3 different towns in 3 different places. You have no way to decide which one to do. In other words, you have no place to put your corrected center. So that's the criterion that says, no, this one you should not georeference. Just another way to think about that one.
So just as a reminder of what we have seen before, we had different kinds of difficult localities that were dubious locations, that are the ones that specifically have question marks or words that indicate that those locations are not really known. There are others that cannot be located, that the locality description says something that we cannot find in any map, in any gazetteer, and it is unfindable. There are the ones that are demonstrably inconsistent that we were talking about now. There are the ones that have more than one matching feature, or where those features are unrelated. And all those cases, in all those cases, we should not georeference. Still, very important, we have mentioned this many times before, we have to document why we're not georeferencing. So we have to use the georeference remarks field to say, we did not georeference this location because blah, blah, blah is inconsistent, or we cannot locate it on any map at this date. It's important to report the date when you're doing it, because at some other time, someone might be able to find it, etc. It's always super important to report why we are not georeferencing. And then there are other difficult localities that are more than one matching feature, but where those features are related and nearby. For example, in here near our house, we have a place, a town that is called Lago Puelo. Lago means lake, but the town is called Lago Puelo. And then there is the actual lake, which is Lago Puelo. And all of that is inside a national park, which is called, guess what? Lago Puelo. And so if we see a locality that says just Lago Puelo, we cannot say if it's the town, if it's the national park, or if it's actually the lake. But we know that those features are related and are nearby. So we can make a georeference that includes them all, because we have to make sure that we're accounting for all the different possibilities, but we can still georeference that. So in that case, we do georeference. And another difficult locality is when we have specifically something that has been cultivated or that is captive in a zoo, for example, and we have the location of that zoo or of that botanic garden or laboratory or whatever it is. So in that case, we can also georeference because we know that where that zoo, that museum, or that botanic garden is. So we do georeference that, and we capture the information about the specimen being cultivated or captive in other fields. So this is just a reminder of what to do with these difficult localities. So let me now go back to the quiz, because now we're going to go to the next question of the quiz, which is this one. And we're moving now to Darwin Core. Here we go. So the question is, if a location is within a national park, which Darwin Core term or terms will you use to capture that information? So in this exercise, you are able to type in the name of the Darwin Core term that you would, or terms, could be more than one. I think I allowed three options per person. Which are the terms that you would use to capture that the location is within a national park? So this is the exercise that is also related to the pre-course exercises. And let me stress again that it is super important that you get familiar with the Darwin Core standard, with the definitions of each term, and that you try to understand the kinds of values that each term allows. There are some terms in Darwin Core that require specific values that use control vocabularies. Like, for example, the country code. Remember that in country code, Darwin Core asks that we use the ISO 2-letter code to fill in that field. And there are some other fields that also have recommendations on which values to use. But it's very important that that you get familiar with the standard. We have some messages on the chat. If you could please put them in the exercise, in the Menti exercise. You should go to the web page and paste the code. I'll write it on the chat. Here it says that we have 6 answers, but it's actually the number of words that have been submitted is 4 participants. Down here you can see the amount of people that have sent their answers. We have quite a variety of answers here. Okay, we'll wait a little bit more. But so far, the most voted one is verbatim locality. We have two variants of verbatim locality here. We have locality, and we have other terms suggested. Any more answers coming? Yes. Okay, we have 13. And I see on the screen some different kinds of terms here. I see locality and verbatim locality. I see terms related to coordinates. We have decimal latitude, decimal longitude, and verbatim coordinates down here. I see administrative fields that are country, country code, province, county, municipality. Again, country code down here. There is some distance above the surface, location ID, location remarks, and higher geography. Okay, so we have very different opinions here. So let's start with the most voted term, that is verbatim locality. We're going to assume, because I did not say it in the instructions here, that the location description says blah blah national park. So if that is the case, it is perfectly fine to put it in verbatim locality. And it's not just fine, it is what we should be doing. We should be capturing that. If it's in the original location description, we should be capturing it in verbatim locality. Also, if it's in the original description, or if we can say the location is there, we should be capturing in the locality field. So these two terms are correct: verbatim locality and locality. Let's go to the to ones that are related to elevation and the vertical component, which are distance above the surface and elevation here. So those two terms are meant to capture completely different kinds of information, which are the distance above the surface and the elevation. So that has nothing to do with which national park we're talking about. So in these fields, we only capture distances above the surface, and in this one, in elevation, we capture elevation. We cannot put into those fields blah blah national park. That's not the kind of information that goes into these fields. Each field in Darwin Core is meant to capture a particular piece of information. Then we have the options that you provided for coordinates, and the same applies here. Decimal latitude and decimal longitude are only meant to capture coordinates in decimal format. And in particular, geographic coordinates in the decimal format, decimal latitude and decimal longitude. So we cannot capture blah blah national park using these fields. Of course, I mean, the national park has coordinates that we can associate to it. But what we're trying to see here is, where do we write down blah blah national park? That's what we're trying to see here. So the coordinates here and the verbatim coordinates here, we cannot use those terms to capture the name of the national park. Now we're going to go to the administrative division terms. So we have country and country code and county, province and county and municipality. Those terms are meant to capture administrative divisions. The country is an administrative division. It's either in Ghana, or it's in Gabon, or it's in South Africa. So that's the name of the country. We cannot capture a national park there, because the field is meant to put which country we're talking about for that location. The same happens for the other administrative divisions. For state province, which in Darwin Core, the name is state province of the term, we're capturing the first administrative division within a country. For county, we're capturing the second administrative division for the given country. For municipality, the third administrative division. And country code is in Darwin Core, the ISO 2-letter code that represents the country that we're talking about. So in any of these fields, we can capture the national park, because the national park is not this kind of administrative division. So we cannot use those terms for that. We're going to go now to higher geography. Higher geography is a very interesting term, because in there we can concatenate all the administrative divisions, both either if they are formal, like provinces, counties, and municipality, but also the kinds of divisions that include national parks. So in there, we could, yes, capture the name of the national park. So we would have concatenated the continent, the country, the province, the county, if applicable, the water body, if applicable, the island and island group, if applicable, and we could concatenate a national park name in there. And then we have the other two, I think I'm only missing two, which are location ID and location remarks. Location ID is an identifier. It's meant to contain an identifier, which is a unique code that represents the whole location that we're describing. But that is an identifier is a code by which we can find that location uniquely. And it usually has numbers and letters, a series of numbers or letters that identifies that. It's like when you have your identity card in your country and you have that document or your passport that has a particular number that identifies you uniquely, well, it's a letter, numbers, code that identifies you uniquely. Well, the same happens with the IDs. IDs are codes that identify, in this case, the location uniquely. And ideally, they should be unique, globally unique and resolvable, etc. But in here, we're not meant to capture names of places, for instance. And then finally, we have location remarks that you suggested. In location remarks, what is meant, this term is meant to capture comments about the location. So if you had comments about the location, you could capture it here. And in this particular case, if we're talking about a national park, there could be some situations in which you could use remarks to say some things. For example, if the location has coordinates and higher geography information and stuff, but doesn't say that is within a national park, but you go and look for the coordinates on a map and you say, well, yes, these coordinates are within the park, you could use the location remarks to say, the coordinates are within the national park. You could use it in that way, but this term is meant to capture comments. So the information about national parks should be captured either in locality, in verbatim locality, and in higher geography fields, because otherwise it gets lost as well in the remarks. So those are the comments that I have so far about the terms that you suggested. John, your hand up. Yep.
Yeah, I wanted to comment just a little bit on the location ID proposal. I find that very intriguing, and I think a lot of thought went into that one. In the case where the location is just the national park, I can see the reasoning behind the location ID being the field to capture the identifier for the national park. I think that's very good thinking. The thing is, the intention of the question was, where do you put the name of the national park? Suppose it's just says Masai Mara National Park. The location ID wouldn't work for that because it's not a global unique identifier in the way that IDs are meant to be in Darwin Core. So the name of the national park would need to go into one of those other fields like verbatim locality, or higher geography. But the idea about the location ID identifying the national park is a very good one. Good thinking.
Okay, thanks, John. So we have reviewed all the, I believe I haven't missed any of the terms that you suggested. So I'm going back to the presentation now. And I put a couple of hearts here because I know Darwin Core is a monster to most people when they first use it, and a little later as well. But you will believe me, you will end up liking it. So what I would like you to do now is to tell me, for this location on the screen, where would you capture each piece of information, in which Darwin core fields? This is very similar to what we've done in the pre-course exercise. So you can do this on the chat, or you can write directly on the screen. You can annotate the screen if you want, or you can just open your microphone and talk to everyone.
Did you explain how they can annotate the screen?
Oh, here.
I'm not sure I can, which is why I asked. I've tried clicking on it to do things, but I can't.
Well,
Fabrice figured it out. I don't. Annotate. Yes, there's a small icon in the very lower left of the screen that looks like a pencil. And next to it is the word annotate if you highlight it. If you click on that, you should be able to write on the screen.
Also, within the annotate, when you open that annotate option, you have different ways in which you can annotate. You have a little pencil where you can draw, or you have a text box that you can click on, and you can start writing in the text box, and it will appear as text. Or otherwise, you can always open up your microphone. We have a couple of comments on the chat, location, remarks, and province. But we need you to tell us what you would put in which field. If you would put the whole thing that is on the screen, the whole description, or part of it, and in case it's part of it, which part, etc. So I cannot see if you're typing on the chat. I cannot see who's typing, so I cannot know if you're trying to answer or not.
There was one nice answer that appeared in the chat and then disappeared. I don't know how that happened.
I don't know either. But maybe what we could do, maybe it's going to be easier. I'm going to. Okay, we have one answer there. Giles is saying Bule Hora. I hope I'm pronouncing that correctly, would go to municipality. Oromia would go to county. Ethiopia would go to country, I assume. Do you agree, disagree with that? The rest? No answers so far, aside from Giles? Okay, Raymond is suggesting decimal latitude, decimal longitude. What would you put in those fields? Oh, I missed that. Where maybe just to you, because I can't see that in the chat. Huh?
Michael suggested that the numbers, the first one should go to verbatim latitude, the second one should go to verbatim longitude, and that the country code should be ETH.
Okay, so we have this and that for verbatim latitude and longitude. That's fine. That's correct. Also, we could put that, as Raymond was suggesting, into decimal latitude and decimal longitude, because those are decimal coordinates. So they should go in both, and also in verbatim coordinates, both of them. So we have solved the coordinates part. That's great. About what you were saying before, municipality, province, country, etc. It is correct. Buleora should go to municipality. Oromia, I believe, if I remember correctly from when I built this exercise, I believe Oromia should go into state province because it's the first administrative division within Ethiopia. So it shouldn't go to county, but to state province. You can later look for it in Wikipedia or some other source, and you will see that this is the first administrative division. So it should go to state province. Ethiopia should go to country. That's correct. And then into country code, careful, because country code in Darwin Core requires a 2-letter code. So it would be ET for Ethiopia and not ETH, just ET. Then we have university building on A8. Giles is suggesting to put it in location remarks. Well, actually, university building on A8 is the actual location. It's the most specific part of the location. It's telling us the location is at the university building on this A8, which is a route, which is a road. So that should go into locality, the locality field. Yes, John.
A comment then. So what would you put in location remarks? It would be something like that the university building was constructed in 1970. It's about the place. It's not the place itself.
Okay, so Ben here is suggesting that in verbatim locality, we put university building on A8. And I'm not sure if he's suggesting that we put everything, or that then in country we put Ethiopia and then we use the other terms for latitude, longitude, and a date. But to clarify, the verbatim locality should have all that is on the screen. Because it's verbatim, it's the original information that we have. It doesn't matter if it's right, if it's wrong, if it has mistakes, if it has misspellings. For example, if here we had university and we were missing the V, we should write it exactly as it says in the original. That's the verbatim. The verbatim locality should capture the information as it is. So all of it should go into the verbatim locality field. And now about the date here, it says recorded April 2021. This means that someone either collected the specimen or observed a specimen in that date, that month and year. So this is clearly not about the location, but it's about the date that was recorded. So this we would not include as part of the location information, except from we could include it in verbatim locality because it's there. Is in the location information that we got. But it's truly not about that. So this will go into other fields in Darwin Core that have to do with dates of the event, when was recorded or observed. It is not a georeference date because it says it was recorded in this month and year. It doesn't say that it was georeferenced in this date. And also, it is not georeferenced, actually, because remember that having coordinates is not the same as having a georeference. A georeference requires 3 elements, at least 3 elements, at a minimum. Coordinates, datum, geodetic datum, so that those coordinates can be actually placed uniquely on space, and an uncertainty. Always, georeference has an uncertainty associated with the location. So 3 elements: coordinates, datum, and uncertainty. If we don't have one of those, it's not georeference. So we wouldn't have a georeference date, we wouldn't have any of that. Okay, so I think we're done with this example. I'm going to pass to another one, which is, oh, let me disannotate, clear all drawings. There. This is the next example, that, and I think the last one we're going to see today, which is a national park. It says Molen National Park, Lobe River, Northern Ghana, Research Station, coordinates unreadable. And the exercise is exactly the same. Where will we capture this information? Which Darwin Core terms we use to capture each piece of information in this description? So I'm going to start with the first part, which is this one, because we have discussed this before. Mole National Park, we saw that we can put it in locality, verbatim locality, and higher geography, right? So we're going to include it in those fields. Nestor is suggesting water body, and that's very, very correct. What will we put in water body? This part here, Lobe River. So the Lobe River would go into water body. Where will we put Northern Ghana? And this is tricky. Because, well, Ghana, I think, is more or less obvious. We will put it in country, the country Ghana. And we would also use the GH code to complete country code. That's the country code for Ghana. Now, what will we do with the northern part? Well, we have to be careful because for some countries, northern, southern, western, etc., are actually administrative divisions, but not in the case of Ghana. Ghana doesn't have their first administrative divisions or second don't have these kind of denominations. So northern Ghana is just, well, in the north part of Ghana. So the only place where we can capture this information is in the locality and verbatim locality fields. So going to locality, what will we capture in locality? Well, we could capture all this. I'm gonna put it in another color to show what we would capture in locality. Locality, Lobby River, and we could actually put it all, because research station would be the most specific part of the location, but alone doesn't say anything. It's a research station in the Model National Park by the Lobby River. So we should capture it all in location, and we should capture in locality, sorry, and we should capture what in verbatim locality. Who can tell me what we'll capture in verbatim locality? Anyone? Exactly, everything. Exactly, excellent. We will capture all of this in verbatim locality, all of the description. Perfect. Now, can we do anything else with this? Well, coordinates unreadable. Well, we don't have coordinates. So all the fields that refer to coordinates, decimal latitude, decimal longitude, verbatim latitude, verbatim longitude, verbatim coordinates are going to be empty. This means no dashes, no periods, no NAs, no nothing. Empty those fields. If we don't have the information, we don't type in anything. Okay. And the same will happen with other fields like all the elevation, because we have no elevation information, and the datum, and all the rest of the fields, because we cannot fill in anything else. Yeah. So that would be the minimum things that we can do with this location description. John, yeah.
Yeah, a clarification. Ghana actually does have a region in the first administrative level called Northern.
Oh.
It's the Northern region, but the way that this is written, we don't know for sure if they mean Northern region of Ghana or if they mean the northern part of Ghana. So we would have to be clear about how we did this interpretation.
Yeah, thanks for that. I was mistaken. Yes, there is one hand up. Yep.
Okay, so I think I want to add something to what John just said. So, and really, the Moli National Park is in the northern part of Ghana. So maybe that's some information.
So the the combination of information here with the Mole National Park being in the northern part of Ghana would tell us that it's not the northern region of Ghana, but rather the northern part of Ghana. Is that what you're telling us?
Yeah, I'm saying that the Mole National Park is in the northern region of Ghana.
Oh, it's all within the northern region. So
Yes.
it's a confirmation that northern would be a perfectly reasonable thing to add for state province for this record, which in itself is something very important that will come up. Why do we have georeferencing centers in 4 different places in Africa? Because hopefully we have people with expertise in the regions, and this is a perfect example.
Yes, thank you very much for that clarification. Has everyone understood what we were discussing just now? Yes, no, thumbs up. Well, I don't see any comments to the contrary. Well, George says yes. Okay, excellent. Okay, so these were the two examples that that we wanted to discuss with you. There are similarities with the pre-course exercise, and about all the exercises that we have tried today, you will see that the exercise from module 1 have similarities as well. Of course, they are not the same, and you would probably have to go back to the modules and review concepts to be able to resolve the exercise that are due tomorrow. And now, oops, I have a lot of lines of annotation here. Yeah, John wants to say something. Yeah, go ahead.
I want to make a quick comment about the pre-course exercises. There was a slight difference in those from what we were really trying to do here with the two examples today. The difference was there, we asked you to try to fill in as many possible Darwin core fields that you could. In other words, sometimes there was information that you could find out and fill into Darwin core fields that wasn't actually written in the description. And so there it was really an exercise to be as complete as possible. Fill in as much of Darwin core as you could from the information that you were given.
Yeah, we have a question from Fabrice. I believe that you're asking us to go back and clarify how this, how this will be resolved. Is that correct? Okay, so what we would fill in is the following. We would put Ghana in the country field, GH in country code, which is the Ghana country code. We would put Northern Ghana in state province. We would put Lobe River in water body. We will put all that is on the screen, all the description in verbatim locality. We would put Malden National Park, Lobe River, Northern Ghana Research Station. We can use all that to fill in the locality field. We can also put only Malden National Park, Lobe River Research Station, ? Without putting Northern Ghana, if we're putting Northern Ghana state province, that in the locality field. We would also be able to fill in the higher geography field, where we would concatenate Africa, which is the continent. We can also fill in the continent Africa, Ghana, Northern Ghana, Lobe River, Malden National Park. We can concatenate all that in higher geography. And then all the rest of the fields, I guess I'm not forgetting any. All the rest of the field will be left empty until we actually look for this and georeference it or look for coordinates and stuff. Because from this description alone, we cannot say anything else. Is that clear now? Okay. So, excellent. I am very happy that we could look at these exercises together. Hopefully, this has helped clarify some concepts. With this, we are ready to finish, unless you have questions that you want to ask now. The microphones are open. Yes,
yeah, I have a question.
Go ahead. I'll go after.
Oh, okay. Sorry. So for the pre-course exercise, there was, I think for the first example, it was Egypt, Aswan, Nile River, and whatnot. So on the part of municipality, like when you're searching that up, how exactly do you just Wikipedia, or is there a specific website that gives you these details? Because I mean, sometimes it's difficult when you're not from there. It's easy to assume maybe that AS1 was the last, like was the lowest administrative level. So I just wanted to know how you know and how you could tell the difference easier. Yeah.
Thank you for that question. Can I say that? Okay. It's a very important one, the question, because sometimes it's really, really difficult. And we have to use multiple sources to be able to find the information. And indeed, we had the exercise resolved on our side so that we can compare our answers to all of yours. And we found that some of you had found another administrative level that we had not been able to find. So we had to do some more research to see if that was correct, and we actually incorporated into our own resolution. So that I'm telling you this so that you can see that all of us are at the same level and have the same problems, because the sources are not exhaustive. They are many times not complete, sometimes are inconsistent. We're going to see this in the last module of the course, which sources to trust and what not to trust and where to be careful. But even though we provided you with a solution that might have been more complete than yours in some cases, don't get desperate. If you don't find the information, don't make it up. Just work with what you have. Of course, one has to put as much effort as one can, but there is also a balance between putting thousands of hours looking for some information that we may not find and moving on to another location to georeference. So yes, it is difficult. We found, in general, the information of the pre-course exercises in Wikipedia, but you have to dig a little bit sometimes to actually get to that. Is what the reality is about the information sources. John, you want to add anything?
Those were all the things that I was actually going to say when you began, but you made me think of another one. And that is, when we get into the project of georeferencing, what we'll have are a whole database of locations to try to resolve. And one thing that happens quite often is you'll georeference a location and you think that you have everything just fine and as specific as you can. And then sometime later you encounter another location that's very similar, but it has more information in it, more information that allows you to do better on a previous georeference. So one of the strategies for georeferencing in the large scale is to try to put together all of the locations that are somehow related to each other. In our project here, we'll try to do that by organizing locations within higher geographic sets. So within a particular state province level, if we can, within a particular county level, etc., so that you're encountering all the similar locations, same basic places on the map at the same time, and you can learn from each of them as you go through and maybe find the answers to some mysteries, to what would be mysteries in some locations that are answered by other ones. So that's a lot of fun. It gets to be kind of addictive when we get into the georeferencing itself.
All right, thank you.
Okay. If you don't have any more, oh, we have a hand up. Go ahead.
All right. I might take you back a little bit, but what I wanted to ask, I don't know whether it was, I missed a point at some point. you mentioned that a country code is a 2-letter word, and you also have the country put in a verbatim, in the verbatim locality. But when we put it there, I think it was a 3-letter code for the country, that is. Or was I just mistaken? Or possibly I missed something.
No, it's a good question. Let me go back to the example.
Yeah, when you gave the example where you had Ethiopia, you said country had to be ET, country code had to be ET, but when you came to the locality, it was ETH.
Yes.
Yeah, okay. So was it a mistake, or that's how it's supposed to be?
No, that is how it's supposed to be, because in the verbatim, we have to write exactly what is in the original. And in this case, this is what is in the original. So we cannot modify anything of it, because the idea of verbatim fields is that we have the original information, so that if we make mistakes when we're interpreting the location, those mistakes can be corrected by going and looking again at the original information. So the original is captured always in verbatim fields, and it has to be exactly as it is. It doesn't matter if it has mistakes, if it has misspellings, it's exactly as it is. Now, that's for the verbatim fields. When we fill in the country code, we're putting specifically the 2-letter ISO code for the country. To do that, of course, we have to interpret this, because we read this location description and we say, well, I am interpreting that ETH refers to Ethiopia. And so I choose to say this is in Ethiopia, and hence for Ethiopia, the country code, the 2-letter country code is ET. And Darwin Core requires that in the country code, we use only the 2-letter code. So that's why we will put the 2-letter. We're interpreting this to fill in the country code. Does that answer your question?
Yes, it helps. Thank you.
Sure. So Nestor is asking in exercise 2, module 1, I have some difficulties to answer the question about entity extent, and we need clarification. Well, about entity extents, let me go back here to some things that we have not seen today. There were some other examples that we didn't get time to use. This is another example. It's not from the exercise itself, but it will serve to show. Here we have a crater, a volcano crater. There is a Nivaldinho crater in Mozambique. So if this is our feature, the feature that we're interested in, the crater, and we want to determine the extent, what we have to do first is determine which are the borders, the boundary of this feature, which might be difficult because, as you can see, well, one may say it's right here, and let me annotate on it. So someone may say, well, the limit of this crater is around here, right? So like that. Okay. And some other of you may come and say, no, I think the crater goes up here and includes all of this. And I would put it a little more here and a little more there. And to me, the crater is all that. And someone will come and say, well, no, the line is just the line up here. Is the border, the crest of the crater. So as you can see, this is a feature that doesn't have an obvious extent, is without obvious extent. And so determining the boundaries of it is somewhat arbitrary, right? So we have to make a decision here on how we draw the boundary. Once we draw the boundary, we have to estimate the extent of that feature. So let me stay with my first boundary, suppose that I decide that this is these are the limits of the crater, the extent would be all this area that is included within that boundary. All that is in here, all that area in square kilometers or in square meters would be the extent of my feature. This is something that we have to estimate, of course, and there are tools. We're going to see how to use these tools. If some of you are already familiar with Google Earth allows you to draw polygons and to get the area inside the polygon. If you're not familiar with that yet, you should try to estimate just looking at it. We don't have the scale on this map, it's cut, but by looking at the scale, you should be able to calculate more or less. For the exercises, more or less, we're not asking for decimal places in the meters, but an approximation of what is the area included in that that includes that feature. Does this clarify, or you have further questions, Nestor?
Okay, it's clear, but I know that we just need to give some approximate approximated value and not exact value.
Yes, yes, you can give it approximate. If you're using some tools, as I said, like Google Earth, and you draw the polygon, you will have an exact value, but obviously that value will depend on where you draw the polygon. If I keep my yellow polygon here, I will have a value, but if I go back to, well, no, this is a little more outside, the value will vary. Even though it might be an exact value, it can vary. So when we review your exercises, we take into account that. So don't worry about this. It's approximate. So to understand if you have understood the concept of extent and okay.
Okay, thank you.
Sure. I saw 2 hands up before, but I don't see them anymore. So if they are up still, then you want to ask? Yes. I see Nara Shaw raised hand.
This is not a question though. So I think this is in relation to how we respond to our emails. I would suggest that for the that if you are responding to maybe emails from your end, from the trainers, we use the reply option than the reply all. So sometimes when people reply, or you tend to lose some of the mail from the trainers. So I think if you could look at it so that we don't make it difficult to kind of track important information from you. Like I was trying to find a email from the, like you uploaded something, I was trying to, because people were using the reply all option, I was finding it difficult to kind of track it.
Yes, thank you for that comment. Yeah, we have had some people answering to everyone, and it's a good practice if you, unless it's something that is going to be important for everyone, if you want to answer us, just answer to John and myself, so that the rest of the people don't get all those answers and it gets very, very crowded, the email. I will try to send separate emails if that helps. Like today, I'm going to send a separate email with the link to the recorded video for today, so that it doesn't get mixed up with the rest. Are there any more questions? Questions, comments? Okay, so if there aren't any more, we're going to finish our session here. We extended it a little bit, but that's fine. And remember that next week we're going to see modules 3 and 4. And so we'll see each other on Monday.